morning, everyone. My name is Scott Crossley. I'm your presenter. I'm working with some fabulous people, namely Luke, who is not here, I don't think, Mihai, Dascalu, who is out of the Polytechnic University in Bucharest, Ryan Baker, who I did see, hi Ryan, who is now at UPenn, and Danielle, McNamara at Arizona State University. We're going to be talking today about predicting success in MOOC data, using both kind of traditional Clickstream data and natural language processing tools. Our interest in MOOCs is the very basic underlying notion that success in MOOCs is notoriously low. And much of MOOC work has focused on kind of predicting this attrition and trying to predict overall success rate. And much of this work has used Clickstream data, demographics, and more recently people have started to look into natural language processing, but this has been done independently, and the basic idea of this presentation, this work, is to combine some of these approaches together. So our current study is going to be looking at natural language processing and Clickstream data only. So ignore any talk that I give you about demographics, because we did not look at demographics yet. We're saving that for LAK 2017, I'm sure. So we definitely want to use a variety of approaches to kind of look at how MOOC success can be predicted. And then we can look at how those predictions can be used to inform some type of either personal feedback to the users of a MOOC and try to get them more interactive in the MOOC and maybe generate greater success in those students that take the MOOC. There's been many studies that have been done on Clickstream and demographic data in MOOCs. If you're not familiar with Clickstream data, I'll give a brief overview of it. It's not really my specialty. I'm a linguist by nature. But Clickstream basically is any logs that are recorded within the system automatically. And they look at how the students and participants interact within that system. So it might be video lectures, the number of times they watch a video lecture, the amount of time they watch a video lecture, the number of times they pause a video lecture. It could be how often they go into the discussion forums, how often they read a discussion forum, how often they write a discussion forum, how often they respond to a discussion forum, how often somebody responds to their discussion forum. A lot of it has to do with assignment scores. So it can be simple things like how well they did on a test or how many assignments they've actually completed. A lot of it can also be done with assignment attempts. So you have 3 or 4 attempts within a MOOC. How many attempts did it take for you to complete it? And then any and all additional course content that is automatically generated by the system. Demographic information is things like gender, age, region, or any type of survey data that is collected early on from the users. It's not always available within a MOOC. So previous studies looking at Clickstream and demographics specifically have looked at student retention, and they get up around 90–95% of accuracy for predicting when student retention is going to occur. A lot of this work is obviously recent, and it looks at things like assignment performance, so quiz grades, and the very basic idea is if you do better on quizzes, you're probably going to stay in the MOOC. And if you're taking those quizzes, you're probably going to stay in the MOOC as well, along with assignment completion. And then, of course, demographic information, such as gender and work experience. People have also looked at student motivation, and they look at and develop kind of engagement profiles using kind of clustering analysis approaches to develop profiles for how and what types of students complete the MOOCs, what types of students are only auditing the MOOCs to learn information but not without doing any of the assignments, what type of students are there that are just they're disengaged from the MOOC in general, or what kind of students are just sampling those MOOCs, and what type of Clickstream data or demographics kind of predicts those 4 different types of profiles for MOOC users. Our previous approach has always been with natural language processing. We offer a number of different kind of tools that are automatically or can be automatically used to assess the language within MOOC forums and MOOC participant quorums. So basically natural language processing is a very easy, simple, I'm going to say easy and simple, an easy and simple approach to understand aspects of cognitive processing that occur through language And it gives you a valid approach to look at things like cohesion, how well a text is representative of kind of the coherence that the reader has, or the writer, the lexicon, or the vocabulary that the writer uses, the syntax, kind of the syntax structure, or also the emotion of the user or the MOOC participant. So we had an initial study that we reported on last year at Educational Data Mining, and I'm going to give you a brief overview of that because we're basically just bootstrapping on top of that. And this is the Big Data in Education MOOC. If you have questions about this MOOC, I would refer you directly to Ryan, who is the professor of this MOOC and the developer and the designer and the genius behind it. But this was the first iteration of it, and this was in 2013. I think it's on the second or third now. But it was basically lecture videos and 8 weekly assignments. There were, I think there was about 40,000 students that signed up for the MOOC. There was about 13,000 students that at least watched one video. There was about 1,200 students that watched all the videos. About 1,400 students completed at least one of the assignments, and about 710 made a post to the weekly discussion section. We are limited because we're interested in natural language processing and we need language, so we can really only look at those 710 students who actually produce something within those MOOC forums. And then we looked at completion rate, and that was defined as someone or a student earning an overall grade average of 70% above. And that was basically calculated by averaging the highest 6 grades. So we had 426 students who made a forum post and completed an assignment, and those were kind of our thresholds. We aggregated the posts together, so basically if a student had 4 or 5 posts, we just added them all together to get an overall profile of the linguistic features and kind of the language approaches that student used. We needed to have at least a decent amount of linguistic coverage, because these natural language processing tools do basically depend on enough words so that we know that it's a complex syntactic structure, or that they have enough words to know that they're using more infrequent words or more concrete words. We set that threshold at over 50 words. So this gave us 320 participants altogether. And that was actually nicely divided between those who completed and those who didn't. So we had 188 that successfully completed the course and 182 that did not. There are a number of natural language processing tools that I've developed along with Danielle McNamara up here and my PhD student, Chris Kyle. The first one is the writing assessment tool. We also have the tool for the automatic analysis of lexical sophistication, and then we have a sentiment analysis tool that we had developed, and those were the tools that we used initially in this first approach and drag. The majority of these tools, the last 2, are freely available online. They come with a nice little guided user interface. No technical knowledge is required to use them. We had a simple analysis of running a MANOVA, followed by a discriminant function analysis to more or less predict the accuracy of whether the students completed the course or did not complete the course. We had a number of indices that were important or predictive within the MANOVA. I know that's a lot of information to take in, so we're going to simplify it and just say, hey, these were the 6 indices, or 7, sorry, that were actually predictive of completion rate within the discriminant function analysis. And you can see things like, and because this was a MOOC and this was focused on educational data mining, if the students used numbers, that was good. Kind of like they were on topic, they were on content. The average post length, this is a bit misleading. It's actually the average sentence length, and the average sentence length showed that people that had shorter sentences were a little more concise, were more likely to finish the MOOC. The standard deviation, hypernymy, is basically how specific words are. The standard deviation basically said that students who used a less range of specific words were more likely to complete the MOOC. We have an essay score algorithm. A lot of the work that I do with Danielle is with the writing pile system, and we develop a number of algorithms to give automatic feedback and summative scoring to users. And so basically think of the essay score algorithm as an overall ability to write proficiently. And of course, those students that had higher essay scores were more likely to complete the MOOC. We also looked at situational cohesion. This is a kind of a mix of things like spatiality, temporality, intentionality across an entire domain, and those students that had greater situational cohesion were more likely to complete the MOOC. Age of acquisition, this basically showed that students that used words that were more difficult were more likely to complete the MOOC. And trigram frequency, those words, or those students, a trigram is just a segmentation or a number of words compared or phrased together. So this is trigram is 3 words together instead of just looking at single words. And those students that used more, a proportion of more likely trigrams were more likely to complete the MOOC. We didn't do too bad. We had an accuracy of about 69%, and that was using solely the linguistic features alone. But then we thought, we can do better. We have all of this data, and we like mining it, so let's see what else we can do. So then we moved on to the current study, so it's the same exact MOOC, same exact student completion rate, same exact discussion post, but this time we used a couple of new natural language processing tools, and we included Clickstream data, and this is where Luke came in and helped out a lot. So some of the similar tools, we used the writing assessment tool, we used the lexical sophistication tool, we use the sentiment analysis and social cognition engine. Please do ignore that, the diacritic above seance. It thinks it's French, but it's not. We also use the tool for the automatic analysis of cohesion, and this is a tool that provides both local and global cohesion, so basically cohesion from sentence to sentence, but then also sentence or cohesion between larger segments, so paragraph to paragraph or text to text. And Mihai has developed a really cool tool called Reader Bench that we also included. And this does a lot more like social networking analyses and things like that. So this was our Clickstream data. We ensured that we used no performance data at all because we wanted to look at data that was more indicative of either language or just their routines or patterns. And plus, we thought it was kind of cheating to use performance data. So we looked at lecture view data, and because a lot of these students didn't complete the MOOC, we were looking specifically at how often they completed this Clickstream data within the week that they were active. So it wasn't averaged across the entire course. So the lecture view data is basically how many times did you look at lectures per your active week, how many videos or lectures were available that you actually looked at, that you accessed within that week. We looked at interaction in forums, so how often the student accessed a forum, and this is by active week 2. And also how many times they upvoted or downvoted a forum post. This was one of the criteria that you could use within the forum posting software. We looked at page views, so how many times per active week they looked at any page, and also how many times they looked at the syllabus. Like, are you engaged in this course or not? And then we did look at assignment data, but of course it wasn't performance assignment data. We looked at the average time or number of times per active week that they submitted an assignment, and then how quickly students completed their assignment. Did they complete early or did they complete late? Did they wait until the deadline, or were they a couple hours ahead of it? So this is the analysis similar to the previous one. We only looked at normally distributed data. We checked for multicollinearity because a lot of these natural language processing indices can measure the same thing, and we don't want to have that happen. We used MANOVA to basically look at differences between those variables and whether the students completed the MOOC or not. And then we used discriminant function analysis to more or less predict that group membership. And we used cross-validation methods here. This was a leave one out cross-validation method. Ooh, look at all those numbers. Give you some time to look over that if you want to. But what you really are probably interested in is on your left side. Basically, Clickstream variables related to videos viewed. The more videos you viewed, the more likely you were to complete the MOOC. The time before turning in assignments, if you turned it in early, if you were industrious and hardworking, you're more likely to complete that MOOC. The number of times you viewed pages, you were more likely to complete that MOOC. And the number of lectures you viewed. The NLP indices included things like your overall writing proficiency, how fluent you were in your language production, local and global cohesion, so overlap between ideas at the sentence level and at the paragraph level. Sentiment, if you were positive, yay, you were more likely to complete the MOOC. Your use of numbers, again, because again, this is kind of content-based and we're looking at an educational data mining. how sophisticated your vocabulary is, with the idea that those who use more sophisticated vocabulary, more infrequent words, less concrete words, are going to be more successful at completing the MOOC. Your n-gram use, and n-grams, and these are going to be bigrams and trigrams, so your sequences of words, 2 words or 3 words. Named entities, how often you actually use some type of named entity, with the idea that the fewer named entities you use, the more successful you were. And social collaboration. How on topic were you and how well were you collaborating with other members of those groups? What is interesting here, these are all, let's see, do I have a pointer? No. From the top, you'll see the effect size, and it's obvious that the Clickstream variables were the strongest, quite obvious. We ran a nice discriminant function analysis that retained 10 variables, had not a bad cap of 0.543, so a more moderate relationship. But the accuracy was pretty good at 77% prediction rate. So we correctly allocated 247 of the 320 participants that were available. And the leave one out validation was 242 out of those 320 participants for an accuracy of 76%. These were the coefficients. These more or less tell you the size and the strength. You'll see that the average weekly lecture coverage, how often you actually looked at the lectures, was the strongest predictor. As I said before, the average number of entities per sentence, if you didn't concentrate on entities, you were more successful or more likely to proceed. Post length, but this was sentences, so shorter, more concise sentences are going to lead to a more likely completion of the MOOC. Trigram frequency, did you use trigrams that were frequent? And some of these trigrams might be getting that kind of grammar use as well, and I'll show you an example of that in a minute. But those students that were using kind of, I would call them unfortunate trigrams, or less frequent trigrams in the English language, were less likely to complete the MOOC. Your essay score, basically how well you write essays based on this algorithm, was highly predictive. Again, word hyponymy, so specificity. Time before deadline for first attempt, if you turned this in early, you did a pretty good job. And then semantic similarity between all your posts. So if you're talking about the same thing over and over and over again, and you're kind of on topic and on course, then you're going to be more likely to complete the course. Your certainty component score. So this was a sentiment analysis. It's basically how certain your words are. And the more certain you are in your post, the more likely you are to complete the course. And then word meaningfulness. Word meaningfulness is the number of associations per word. And basically, if you produced words that had fewer associations, thus they were more sophisticated, you were more likely to complete the MOOC. So, a quick discussion, because I'm short on time. Variables related to Clickstream data are the most predictive, but we were really happy, I'm really happy because I'm a linguist, to see that those NLP perspectives were also indicative of performance, right? So the Clickstream data, as I just went over, were basically the weekly lecture coverage and how early they submitted their assignments. But look at all those beautiful linguistic features that are also helping to lift people up and over those boundaries of completion in a MOOC. So basically, successful students interacted more with the system. They're much more active in forums. They produced much higher quality writing, and they stayed on topic, which you might expect. But what's nice about this is, of course, we can analyze this automatically, and that could give us a lot of information about how to intervene and try to help students climb to success. Real quick, 2 example students. The one on the top is a student who actually completed. The one on the bottom is one who didn't complete. I'm not going to read it out loud, but I will give you 30 minutes of solace to look through it. On the right-hand side are the actual variables that we completed or computed for them. You can see that the student who completed viewed a lot of videos, also has a shorter kind of sentence length, uses much more frequent trigrams. It had a high essay score of 6, which is pretty incredible to get. You can see that their time before the deadline when they first did the first attempt was way ahead of time and way ahead of schedule, whereas the student who did not complete was not. There's a lot more similarity between paragraphs. This is just one excerpt from the larger one, but as those forum posts continue, they would produce a much more semantic similarity between those paragraphs. There's more certainty and less meaningful words. So takeaway, both linguistic indices and clickstream variables can help improve models of student success, about 10% over what we've used, which is natural language processing variables alone. And this gives us kind of a better understanding of what success within a MOOC is, and how to use kind of multiple sources of data to look at this success and predict this success. We, of course, have a lot of future studies we want to do. We're working with Mihai to do a lot more deeper social network analyses. We'd like to conclude some demographic information. We need to look at MOOCs that have greater language production. So, I mean, we had 40,000 students that initially signed up for this MOOC, and we could only look at 700 of them, more or less, because those were the only ones that produced any language. We'd love to look at how these kind of algorithms and models and these approaches generalize across different domains and different tasks. So other MOOCs, other topics, not just MOOCs, but intelligent tutoring systems or online tutoring systems. And then we want to obviously continue to develop these NLP tools that we've started to develop now. That's it. Questions if you have any. Yeah, in the middle. Yeah.
Have you ever thought about creating some kind of measure to investigate how regularly students study? So now it's an academic measure at the end, so you could binge watch the videos in the end and still qualify as a high.
The aggregated measures were only for the natural language processing measures. So for all the Clickstream, it was done weekly. And it was aggregated at the weekly level, but we didn't look at an overall average, only because we wanted to keep those students that left like at the second or third week. We didn't want to, I guess, disenfranchise them from those Clickstream data.
I mean, like the regularity score,
Mm-hmm.
like on average, were you active every week or were you active in total?
Yeah, we did consider those variables, but we took them out because the problem was most of the MOOC students that dropped around week 6 or week 4. And if we just looked at the overall occurrences across the entire MOOC, then we would have probably 100% prediction accuracy. And we wanted, because if we really want to intervene and we want to keep these students available and capture them before they drop out, we need to be able to do that at the week level. And so we haven't really looked at aggregation.
Sorry, Scott, can I just ask you to repeat the question?
Oh.
Watch the stream and also the other.
Of course, if I can, and I'm not really good at summarizing. She asked if we thought about looking at variables that aggregated over the course, or over the entire course. Yes. Sorry. Yes.
So we can see from this that people who write well and engage with the course tend to be successful.
Yes.
What changes have you made to the course as a result of this, and what interventions do you see coming up in the future as a result of this to help to get more students passing the course?
I'm going to defer this to Ryan. Did you hear the question, Ryan?
I didn't hear it.
Oh, the question was that we found out all this great information because we're fantastic. How is this going to inform the development of your future MOOCs?
It's a great question. I think that one of the things that hopefully we'll be able to do going forward is to kind of take some of these indicators to figure out when a student's writing indicates that they might need more support, and then try to get those students, A, more attention from the instructor and TAs, but B, try to get them in collaborative activities with other students that can help them with some of the things they need to learn a little better.
Does that process all the way over there?
There you go.
Okay, excellent. Chris.
Scott, thanks. I love holistic models, and I think there's a lot of work to bring all these different data sources together in a meaningful and coherent way, and that's really cool here. I'm just a little foggy on the detail of when you built these models and the set of data that you used. So I understand that you've aggregated things down by weeks and you've used text, but were you building a model in week 1, and that's what your kappa reflects, or
No.
it's at week 12?
It's at week 12,
So this is
or week 8 in this case.
okay. So this is a predictive model at the very end of the course,
Yes.
as to whether they're going to complete the course
Yes.
or not.
But in a lot of cases, I think that's what I just said was disingenuous. So in a lot of cases, these people that didn't complete the course, they might have stopped processing or using the course around week 4, and that's the data we had on them. We just stopped at week 4 for them because that's all the data we had.
And have you considered testing on a subsequent run of the class to see how predictive it is of a new cohort?
Yes. In fact, we have another run of your MOOC from 2015 or.
That's right. I think we finally got the data to you guys like 6 weeks ago or something. So sorry that it took us a while, but yeah.
Yeah, great. But yes, absolutely. Thanks. Oh, in the back. Oh, I don't know who he is, so perhaps not.
I'm back to the first question, actually. One of the great value of combining Clickstream with NLP is the time dynamics. And in all the variables about the Clickstream, you have average values. So you lose a slope. Somebody who moves from positive to negative, from negative to positive, are the same people for you, but instead of predicting dropout, they're completely different. So maybe that's explained why you get only 10% increase of accuracy with the Clickstream, is that you lose maybe the most interesting information, which is the time dynamics.
That could absolutely and totally be accurate. Yes. No, and yeah, and I'm not going to defer, but I'm going to say, as a linguist, I'm really into this natural language processing stuff, and I will.
Okay, that was a message for Danielle.
Oh, that was a message for Danielle.
The overall goal of the grant is to combine these variables from multiple sources. We're only on essentially level 2 right now, combining Clickstream and NLP, and then also to create temporal analyses such that we can combine the data as it comes in and then be able to essentially predict the student. And ideally, you'd be able to use whatever data that is available, not just if they have NLP and then you're only looking at the NLP flow. That sounds stupid, but it's just what we're going to do right now at a simplistic level. I mean, and ideally, what you have are models that are more flexible and come together with whatever information you have so that you can intervene. And from my own perspective, so for example, one of the things that one gathers from this is that, students are better readers and writers who are finishing these MOOCs. So what we want to do is look at how that extends across a variety of courses to see if this will generalize. And then what can we do? Maybe we can give them tutoring technologies or redirect them into interventions that will help them to learn how to better write. So that's the ultimate goal. But this is kind of,
Yeah, and we've started doing temporal analysis as well with colleagues in Romania, and we plan on running that up, and we got really fantastic accuracy rates on those. So.
Today at 3 there will be some talk by Mihai on some of the temporal analysis done on some of the Clickstream data.
So I know we have a few more questions, but unfortunately we're almost out of time, and I'm going to use the prerogative of having the mic in my hand to throw one last one out there, which is because I hear something in a lot of these questions, which is this is an exciting prediction, exciting combining the data, but how do you take action? So the questions about looking at the temporal patterns in the data to make better predictions, as well as Chris's question about when are you looking at the data to intervene in a timely way. So I want to add to that an action-based question, which is, to what extent are you identifying sort of indicators of successful students versus causal factors? So Danielle started to speak to that with the writing training, but I worry that these are indicators of things of students who are doing well, but not necessarily, telling a student to click on more videos would actually change their behavior. So I think that's an important question in all of our post-talk data, and I'm wondering how you're thinking about that or thinking about taking action to address that.
Causality versus, this is just your individual differences, is that what we're collecting? I mean,
not even individual differences, but it was a similar question that people asked in the first presentation about longer posts. I would say that longer posts are a great indicator, perhaps in their work, of somebody who did a better journal reflection, but telling students write a longer post isn't going to make them do that. So it's not about student individual factors as much as we can find things that are good indicators and predictors, but they're not necessarily the points at which we want to intervene and change things. And so how do you take a model that's based on predictors that we don't know are impactful and take action based on that?
Well,
I think there are two aspects to this. One has to do with proxies, and one has to do with I disagree. First, we have to take into account that many of these things are proxies. They are not the construct we are looking for. So an essay score is a proxy for language ability. And we may or may not be able to intervene on that. But we also had other things having to do with collaboration, so social collaboration. We can intervene on social collaboration. We can build tools that induce students to engage in greater social collaboration, and that helps to scaffold them. And Ryan spoke to that. That's one of the goals that they're working toward. But the other thing is actually just telling students to write more has a significant impact on writing quality. So we have empirical evidence on that, where we did an empirical study where we manipulated just telling them to write more. So in that in the first talk, potentially a simple intervention, just write more, stay on topic, could significantly enhance their performance in the course. And same here in terms of the discussion, if we can potentially give them some hints as to, well, why don't you try to stay on topic? Why don't you, do all this stuff? Sometimes simple hints work.